arithmetic sequence. So here in our lesson about finding the nth term of arithmetic sequence, we will be using the formula for the a sub n, which is equal to a sub 1 plus the quantity of n minus 1 times the common difference t. So in this formula, the common difference t is given by the a sub n minus the a sub n minus 1. And the main idea for solving any particular term in the arithmetic sequence using the formula for the nth term is by using the substitution property. Arithmetic means. Obviously, we have to start with the definition of arithmetic means. So the arithmetic means are the terms between any two non-consecutive terms in an arithmetic sequence. So let's say that we are given with the arithmetic sequence a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. The arithmetic means between a sub 1 and a sub 5 are those terms found between them. And those are the a sub 2, the a sub 3, and the a sub 4. Now, let us proceed with the problems involving arithmetic means. And for our first problem, find a arithmetic means between 5 and 68. So the information that we have so far in this question are those 5 and 68. But we need to insert 8 arithmetic means between them. So let us try to illustrate the problem this way. Writing the 5 first, and then we have to provide 8 blank spaces for the 8 arithmetic means, counting 1, 2, 3, 4, 5, 6, 7, and 8. Now we have our other given 68 here. And that brings the total of 10 terms. So remember, we have 2 given terms and we have 8 arithmetic means between them. So far, the only information that we have for this is that we could make an assumption that the 5 is our first term, writing a sub 1, and our 68 being our 10th term, denoted as a sub 10. And we have also learned in the previous lesson that we can come up with any particular term in the sequence using the nth formula for the arithmetic sequence, which is the a sub n equals a sub 1 plus the quantity of n minus 1 times the common difference t. If we try to run a data sufficiency test for this using all the information provided in our problem, then we may assume one particular term for our a sub n, and that would be our a sub n, for which we will have a value that replaces the a sub n in our formula. Knowing that we have our a sub 10, for which the n right here corresponds with the 10, then there will also be a value that replaces the n in our formula. While the a sub 1 obviously is given to be 5. And now, if we take a look at this formula, we are only left with one unknown value, which happens to be the common difference. So that means we can make use of this same formula for us to find the value of the common difference. But how we will be able to make use of such information about the common difference for us to know the arithmetic means in the problem? Once we have the value of the common difference, we will be adding such value to 5 so that we get the second value. And using the second value being added to the common difference, that gives us the third value. So by merely repeating that same procedure, that reveals all the arithmetic means in this problem. So arithmetic series. So here the formula to be used for this lesson is first the S sub n, which is equal to n times the quantity of a sub 1 plus a sub n all over 2. While the other formula is S sub n, which is equal to n times the quantity of 2 a sub 1 plus the quantity of n minus 1 times the all over 2. So now let us talk about how we will be able to apply such formula and what is the appropriate formula for one particular situation. So the first formula right here is usually applied when the information given in the problem are those values of the first term and the nth term. So meaning, we are given with the information of the a sub 1 as well as the a sub n. While in the other formula, so here, we must have a known information with regards to the values of a sub 1 and the common difference. And to further understand the idea regarding the use of these formulas,